This is the part of the lesson where we're going to do some radical equation examples. So let's solve these. Remember, we're going to isolate, then we're going to put both sides to the index, and then we're going to solve and check our answers. So this first one, we want to add 5 to both sides. I can't get rid of this 4 because it's under the square root, but I can get rid of this minus 5 because it's outside the square root. So I've got square root of 2x plus 4 equals, when I add 5, I get 6. Now I want to get rid of that square root, so you're going to square both sides. So 2x plus 4 equals 6 squared, which is 36. Now I can subtract the 4 and I can divide by the 2. So subtract 4, you get 32. Divide by 2, you get x equal to 16. Let's do our check to see if that works. Put it back in the original. Is the square root of 2 times 16 plus 4 minus 5 equal to 1? Well, 2 times 16 is 32. 32 plus 4 is 36. Square root of 36 is 6. 6 minus 5 equals 1. It checks. So we're good. Let's try the next one. This one, you've got square roots on both sides of the equation. So both radicals are already isolated. Now, sometimes you're going to find when you do that, you're going to be able to just square both sides right away to get rid of those radicals. So we'll get rid of it on both sides. So let's do that. I'm going to square this one and get just x plus 5, gets rid of the square root. Square this one, I get 3x plus 21. No more square roots by squaring both sides. Now let's go ahead and subtract 5 from, let's subtract x from both sides. So 5 equals 2x plus 21. Subtract 21 from both sides. And when we do that, we've got 2x equal to negative 16. X equals negative 8. Okay, for that. So now I'm going to check that. And when I do that, if we're solving over the real numbers, this would not work. But we can solve over imaginary numbers. Remember, if we have a negative root, if it's on both sides, we can do that. So I'm going to check by saying square root of negative 8 plus 5 is negative 3. Does that equal square root of 3 times negative 8 plus 21? And when I do 3 times negative 8, I get negative 24 plus 21. I get square root of negative 3 equals the square root of negative 3. Which means it's the same thing as I times the square root of 3. So if we're solving over the complex numbers, this does check. Okay, so if the directions say solve over reals, we would say you can't do that underneath the square root. But if we're solving over imaginary numbers and complex numbers, it is a solution. Okay, let's try this one. First of all, I want to get the square root by itself, so I'm going to subtract 10. 6 square roots of x plus 2 equals, in this case, we're going to have 24. Divide both sides by 6. Square root of x plus 2 equals 4. Now I'm going to square both sides to get rid of that radical. So I'm going to get x plus 2 equals 16. Subtract 2 and you get 14. Let's do our check. And so when I check it, I'm going to have 6 times 14 plus 2 is the square root of 16 plus 10. Does that equal 34? That's 6 times 4 plus 10. Does that equal 34? And it does. So it checks. So that's our solution is 14. And then lastly, on this one, it's a cube root, so we can get it by itself. So subtract 8 from both sides. Cube root of x equals a negative 6. Now you can put both sides, you can put negatives to an odd power. So I'm going to put both sides to the third power, negative 6 cubed. Make sure you put parentheses around the negative 6. So you do negative 6 times negative 6 times negative 6, you get negative 216. And now when you check it, 8 plus the cube root of negative 216, no imaginary numbers needed here. When it's an odd root, you can have negatives under there. So that's 8 plus -6. Does that equal 2? And it does, so it checks. So in solving our steps, make sure you isolate. Make sure you then put both sides to that power of the index. Then you go ahead and solve and then check your answers.